So a very good afternoon to all of you. Today I will discuss with you people the continuation part of the generating station that we have started on yesterday lecture. On yesterday lecture, we were discussed about the generating station. These generating stations are also called as the power stations, and the power stations or the generating stations are those stations where we can generate the electricity by converting one form of energy into another energy. For example, if we convert the hydro energy into electrical energy, the generating station is known as hydroelectric power station. If you convert the fuel energy of the coal into electricity, then it is called as the thermal power plant. And if you use a nuclear fuels energy in order to boil down the water gets converted into the steam, and after that this steam will strike to the turbine, and turbine is coupled with the alternator, and this alternator will generate the electricity. Then this type of power station or a generating station is known as nuclear power plant. And also we have a gas power plant where we are using a gas or something another fuel for generation of steam, and when this steam strikes to the turbine, this turbine is coupled with the alternator, and when the turbine coupled with the alternator, your electricity will be generated. So this is all about the generating station. And in yesterday lecture, I had discussed with you people the generating stations, and in generating station I would start hydroelectric power station. And in our previous lecture, I was discussed with you people about the hydroelectric power station. What are the different types of hydroelectric power station in which we can use a dam, we can use a runoff river scheme, we are use a pump storage, and there is a small video. We have a concept related to the generation of electricity through hydropower. Now today it is a continuation part of the generating station, that is hydroelectric power station. So the very first we have the power generated by the hydroelectric power plant. How much a power can be generated by the hydroelectric power plant? For example, if I talk about in our J&K state, we have Baglihar hydroelectric power project, and this Baglihar hydroelectric power project, the total installed capacity is 900 megawatt, that it can generate a 900 megawatt, which will be divided into two main stages, the stage 1 and the stage 2. The stage 1 is having 450 megawatts and the stage 2 is having 450 megawatts. And if I talk about the another generating station, that is a Salal hydroelectric power station, the generating capacity of the Salal hydroelectric power station is 690 megawatt. And this 690 megawatt will be generated by again the two stages, that is the stage 1 and the stage 2. And in stage 1 there are three generators, each having capacity of 15 megawatts. So the total capacity of the Salal is 690 megawatt. So the question comes that how a power generated by the hydroelectric power plant can be defined. How much power it can generated in any of the hydroelectric power plant, and the power generated by any of the hydroelectric power plant is given by the equation, that is P is equals to efficiency rho Q G and H. This is the power equation of any of the hydroelectric power plant, where P is the power in watt, efficiency is the dimensionless efficiency of the turbine, and generally this efficiency we have taken about 90% to 95%, because you can say that in any of the hydroelectric power station the efficiency of the turbine that can be used is about 90 to 95%. Rho is the density of the water, and this density of the water is always fixed, that is 1000 kg per meter cube. Q is the volumetric flow rate. Volumetric flow rate means at what flow the water is striking at the jet of the turbine so that the turbine will start rotating. G is acceleration due to gravity. There is a constant value 9.8 meter per second. And you know, in any of the hydroelectric power station, the water is flowing from high height to a low height. That means when the water is flowing from high potential to the low potential, the acceleration due to the gravity and is having a value 9.81 meter per second square is also introduced in calculating the power of any hydroelectric power station. Lastly, we have H, that is the height of difference between the inlet and the outlet. Now, after that, I will discuss with you the various constitutions part of the hydroelectric power plant, where you have to discuss what are the main parts of hydroelectric power plant. So, once you can get an idea about the efficiency, that is 90 to 95%, rho is the density of the water, that is 1000 kg per meter cube. Q is the volumetric flow rate, G is the acceleration due to gravity, and H is the difference in between inlet and outlet. You can easily calculate the value of power generated by any of the hydroelectric power plant. Now, one most important thing that you must kept in mind while calculating the power in case of any hydroelectric power plant is that you can see from this equation, this efficiency is a constant value. Your density of the water is also a constant value. That is, efficiency is about 90 to 95%. Efficiency is 1000 kg per meter cube. G, that is the acceleration due to gravity, is again a constant value, that is 9.81 meter per second square. So only the power of the hydroelectric power station will depend upon the two main things. One is the volumetric flow rate, and another is the difference between the height between the inlet and the outlet wall. So you can say that in any of the hydroelectric power station, the amount of power that the hydroelectric power can generate is ultimately dependent upon the two main things. One is the volumetric flow rate, and another is the height of the difference between the inlet and the outlet wall. I think up till this, it is a clear to all of you. It is a clear? Yeah, it is clear?
Yes, sir.
Okay.
Yes, sir.
So this is basically the layout of any of the hydroelectric power plant. Now you can see the layout of hydroelectric power plant. There are different type of constitutions, or you can say the different parts of this hydroelectric power plant. You can see there is a called as the head pond. I will discuss it later on. You have this intake. After that, you have this. After that, you have the water. Yeah, it is a scene to all of you now. So the water is flowing from here, and this tunnel is basically, or this pipeline is basically called as the penstock. After this, water will strike the turbine. This is called as the turbine. The water is strike the blades of the turbine. The turbine start rotating. This turbine is coupled with the shaft of the generator, uh, and this shaft will start rotating. And after that, this generator will start rotating. Now the water that rotates the turbine, after that this water will be get to the draft tube, and after that it will be go to the river by the means of the tail race. Now from this generator, your three-phase power will be generated. It is transferred to the transformers, that is called as the step-up transformers, and after that we have a transmission line. This, yeah, it is audible.